Okay, so we're on module 6. This is the halfway mark. And it's instructive to tell you that module 6 and 7 are the same material. So um, these documents are going to be used in 7 as well. There'll be different exercises and things, just to test you, but mm, yeah, and some of these are also for the next module. I guess I could move those over. I thought I moved those. Let me make a note. All right. So in the notes, I have to look at the English. So you should for to complete for today should be up until here. So page 15 is the beginning of module 7. And these, oh, not there. Let me close. No, well, these here videos should probably be in 7. What page did I say? 15? No, 15 starts module 7. So maybe I'll put a note so then I don't have to move them. So, this stuff is module 7. The main thing is to get through the the rules. I want you to get through all the probability rules, and my belief is that most of you have an intuition for probability. It's kind of hardwired into us. But then there's some misunderstandings that I try and clarify, and I use terminology to do that. For instance, what is the difference between independent, mutually exclusive, complementary events? This terminology, how do I know what's independent and disjoint? Are those different? Okay, so that's what I begin with. So I do give you an overview. Let me see, let me clarify. Is that what I do at the beginning here? No, I do this. All right. So in the video around here, I present this overview and I go through all the different terminology with pictures so that you better understand. Maybe you've heard these terms before, you've heard these terms, and I'm just trying to tease them apart with pictures. How many of you did not start module 6? How many did not start module 6, just so I have an idea? That's right, Giovanna. For today, it's up to page 14, and module 7 begins on 15. And I should put that in Moodle. So, so yes, I'm recording today. I just turned the recording on. I usually record and post, unless I forget or something happens. Okay. So, okay, so most of you saw the material. Okay, so then I can ask you, oh, let me go back to the question. So there were 2 questions. One was a comment on the audio of this video starting at 1:16, and I did review it and I am in and out, but I wonder if that was an interruption, just me pausing or being distracted. I don't know. Um, if there's any major gap here, I can place a new recording. I don't know what I said that's missing, but I can give you more complete. Did you feel that, who asked me the question? It was, I think, yeah, Dorimar. Do you feel like there was a lost comprehension there? Was Dorimar here?
Uh, it just took me a little bit, a little bit longer to go through the problem because I had to finish the
Guess what I was saying?
recording.
Okay, so maybe I have to, I wonder, so there were no captions?
I didn't think there were.
Okay, let me see.
I don't remember.
Yeah, because I'm highlighting, but I'm not, there's no sound, right? Should be captions. So it must have really gone off. Some of it's pausing so the students can solve the problems. Entry events.
Yeah.
There's not even captions here.
No, I mean there's definitely audio missing.
Oh, there they are. There they are.
But on the actual problem, but um I think maybe if someone has a question on how to solve it, they can
You
post.
can, yeah, you can ask me. Well, I can do a whole new video and add it for the missing piece. But yeah, I guess it wasn't, nobody's complained. So you're the first one. So I need complaints. Okay, great. I'll add that. And the other question here was regarding problem 15 in the homework. Okay, so homework. So I'm just answering questions. If you have questions, put them in the chat for me. Oh, is this it here? Oh, I put it here. No, did you see this? I think I resolved it. Problem 15, answer is E, not D.
I did not see that, no.
I guess
Okay.
check it out. I don't remember. I kind of remember doing this, but I need to see where. Let me see the problem. 15. That's funny. Yeah, that was probably last year.
Yeah, I was going off the answer on the solution because like the video or somewhere it said it corrected one that was wrong as part of the title, but it didn't include this one. And I didn't see that.
Okay. Okay. So can you check that and then write back in the chat? That's okay.
Mm-hmm.
What's this? Oh, that must have been from my iPad. Okay. At this moment, I don't know where the answer is. Okay, down here. The answer is E, not D. Okay, so let me know. So it's here somewhere that I wrote that. Oh, this is for a different one. Problem 15, 14. Well, hopefully that helps. I don't know. So we're gonna have another week. You're gonna work on finishing probability, right? Okay, so any questions up till page 14 then? No questions. Oh, Bayes rule. Bayes rule is after 14, Nacha. So we can talk about it next week. So next week will be, let me show you. So this week it's just the rules, the basic rules, and the most important one for Bayes rule is understanding the conditional probability. Understanding a conditional probability. No, no, it's okay, Nacha. It's confusing. I agree. It's not clear. I didn't leave it clear because I don't want to discourage studying. If people want to study ahead, and that's fine with me. I'm happy with that because it takes time to sink in. And see, then I go through what I do next. So I introduce the rules. Then I talk about the different kinds of distributions that we're going to use in this class, right? There's hundreds of established distributions, just like the normal distribution was created to um, to represent common pattern identified in nature. There's other natural patterns that have also been modeled, let's say, with statistical distributions. Okay. And I'm going to teach you just a few of them, but I begin with the general discrete ones and I discuss it. And then I talk about, so that's number one in the category of discrete distributions. So I separate between discrete distributions and continuous, remember, because this class is focused on quantitative data and we divide variables as discrete and continuous. So for discrete distributions, the only um, ones I focus on are the general discrete ones and the binomial, and I get really into that in module 8. But at the beginning, you just need to be able to identify what a binomial is separate from a general discrete distribution. And there are other distributions that I have exercises on mostly so that you know the difference. I really want you to be able to identify binomial versus the other ones. The other ones are important too, but there's only so much time in this class. I want you to be an expert in binomial because we need that for sampling theory that we're going to use for inference at the end. That's to look for effects in experiments and yeah, and significant effects and things. We need sampling theory to do that, and binomial is really important for that. All right, so then this is all about the binomial. And see, these are the other two distributions I mentioned. Oh, hold on. Because the sections of the textbook are from the Newcomb, no, not Newcomb, what is it called? Newbold data set. I got to put the reference for, I should just delete that. The reference in the other book. All stats textbooks will mention Poisson and hypergeometric, and you can learn about them. And they're popular because, again, they mimic common phenomena. Poisson is used for estimating arrival times and number of people in like a lineup. So that's very useful for um, preparing enough personnel, like in a bank, or preparing anyway, just it's for things on a manufacturing, like you can use it for delivery and for arrival times in a lineup, things like that. And then hypergeometric is very popular for um it's really used in probability and describes things like picking cards from a deck and what you expect, where in a standard casino deck of cards, you know what to expect and what happens when you change or you take a few, what's left and what are the probabilities. So anyway, so those are the common types of distributions that you learn about. And then the continuous. So there's only three distributions. So going back here, the only two that you really need to know about for this class are binomial, general, and then the Poisson and hypergeometric. I'm not going to like test you officially on them, but it's important to recognize them separate from the binomial. And then I get into continuous distributions, and the ones that are important, I describe the uniform, the normal we already know, and the t. So that's it. Like there's just those distributions you have to be an expert in. So just like the last module, where I listed all the questions you have to be able to answer. Basically, these are all the distributions you need to be an expert at for this class. And then I have this fantastic assignment. I think it's great. And I described this assignment. So that is testing everything you've learned. up to this point, and then I get into Bayes. So Bayes is here, which it looks confusing, but I mean, it's really important. It is very important to understand applying Bayes' rule, and I hope I can make it less confusing. So we'll do that next week. You guys will look at what I got for that because it looks very confusing, this long equation, but it really isn't that bad. And then this is super confusing. Mean and variance of random variables. So do not be intimidated by all this writing. It's better, in my opinion, if you understand everything in the boxes and then read the notes. So watch the video. Hopefully that will help you. And what I do here is I discuss how, because, I was doing midterm and final exams, and on the final exam, um, I expect you to be good at this because this is so intimidating. Students would rather forget about it. But you need to know this. It's going to be on the final exam. And let me remind myself, what are we doing about the final exam? Yeah, yeah, it's 3 hours, right? So we're preparing for that. We need to be expert at a few things, not everything, not everything. But I single this out, like you need to know how to, sorry, I'm over here, how to do this portion of the notes. So we're going to spend time on that next week. So that's why we need 2 weeks for this. Okay, so um, my recommendation is that today, if you haven't done it already, finish up to here, page 32, or this weekend. And then you will have the week to get through the last half that seems different, but it uses all the rules that you learned. Okay, so for this weekend, try and finish up to page 32, which are just exercises. Those are exercises and answers. Sorry, I'm scrolling so fast. Okay, so for this weekend, up to page 32. And then you can spend next week on the rest of it. And then we can have that quiz next week. All right, so let's see. And I'll see if I can fix that video or I'll add a clip. I mean, I don't know what I said if the audio's not there, but usually I say standard things, so I'll make my own video. All right. So any questions? No, don't worry, Nacha. It's fine to ask me. Okay, so I've been recording and I forgot to ask for somebody to do timestamps. Who can I count on for the timestamps today? Like I said, the timestamps just make you more likely to listen carefully. Not a bad thing. Okay, so it's 9:25. Thank you, Alondra. So 9:25, we're starting. Um, we can just call everything up until now. You can just call it overview of what's required for the weekend and for next week, something like that. I'll remember too. All right, so then questions for me about up to page 14 or any, even up to page 32, any questions? Because that's just reviewing all that stuff. No questions? Is all clear? You want me to give you some problems? I'll give you some problems and we'll see how we do. All right, so
I
some
have a
different problems.
question.
Uh-huh.
It's very basic, but I was just wondering, like for the wording, when it's like probability A or B, is it always like the sum of them? And then
Yeah.
when it's that formula like
Intersect.
PA/PB/A.
Well, no, not exactly. Okay, so that's a
Oh,
good
okay.
question, but okay, so the rules to summarize. So we have four, there's actually five pictures. There's actually five pictures. I'll go with the English. This one is complementary. So I tell you what and or are for complementary, and what I call not A or B. And then I do it for pictures like this, and then I do it like pictures like, so what you're saying is it just this or that? Well, it depends on the relationship of the events. And here we have just two events. What if I add another one? Okay, so you have to know the relationship between the events to know what the result is. The main thing I express here is this picture here and this one looks the same. This is the main thing to realize. This picture and this picture look the same. You agree? Pretty much the same. However, this one I call overlapping, and I distinguish that from independent because if A and B are independent, then this piece has what you said at the end. It has a relationship that A and B is the multiplication. This is only the case when you're told they're independent. Otherwise, you don't know that. So let's see. If A and B are not necessarily independent, what is the probability of A and B? Let me ask you that question. Let me open my iPad. And right, so you need to know, so Dorimar is saying, yeah, so or an and, the results, you only know when you know the relationship between them. Okay, so you add them if it's or, only if they're disjoint. And you multiply them only if they're independent. So those rules, those simple rules, have a condition. So you need to know how they're related. So let me,
Yeah, that makes sense now. Thank you. I was watching the video, but I was still confused. I'm like, is it the same thing for all of them?
that's right. It depends on the relationship.
Yeah.
You have to read or look for extra information. So yeah, it's the perfect question actually what you asked. Because and that's what I'm trying to stress, not to fall into that trap that, oh, this and that I just multiply. No, there's a condition. A condition is that you know that they're independent. I think I have it in the notes too. I have it written out. Oops. So that's what you can put. So you guys should right now be preparing that formula sheet or that outline of the course that you just, a few pages in a notebook or a side that you refer to when you do the tests, right? And you're going to have all of that for the exam. So you don't have to make a set of formulas. Although I'm going to give you a formula sheet that I illustrate to you, but have all your own formulas for everything before the final exam ready. Okay, so this is something that's going to go on it. I wrote it in the notes somewhere over here. Sorry, close your eyes if you get dizzy with the scrolling. Because I get dizzy unless I'm in control. Here, right here. This might be what you saw. Find A or B when question states, no, that's not it. Find not A or B. No, that's not it. I wrote it over here. Hold on. That's still important. This one. A or B, add probabilities only if disjoint. I should have just bolded the only if. And probability A and B multiply probabilities only if independent. This is your summary, okay? So I hope that helps. So let's talk about what if they are not. How about that? So let's talk about that. Let's do that. I'm going to take that. Let me export this. So you guys, at 10 o'clock, I'm going to ask you if you want to test today or not and what you want it on. Okay? So otherwise, we're just going to do review today of everything. It can hurt to have the test because, it's good to have more tests to try. But if you feel you want to focus on the review, we'll focus on that till 12 o'clock.
I have a question. Do you mean that we have like a test and then the quiz, or
No, no,
uh,
no. I'm saying just they're the same thing. I'm just saying that we can pass on the test today
okay.
if you want and not have a test, or we can still do it at 11:30. Otherwise, we'll just keep studying.
Okay, otherwise until 12. Okay, the review. Okay. Is
Yeah,
I was like a little bit confused. Okay,
yeah,
thank you.
yeah. Because we're just gonna do reviewing and clarifying and looking at the quizzes. 'Cause you want feedback. You need feedback. Okay, so
Professor, sorry that I'm gonna I don't find the words, but I'm having like trouble contacting you. I write you an email and a text, so I don't know if later in class we can talk. Is
yeah,
that
sure,
can we arrange that or not?
sure, yeah, I can stay. I can stay back. So yeah, we can have this break so we can resolve any questions you have in general with the students. I don't know why I'm not getting them. Are you emailing me? I don't know what happened.
Oh, I got scared.
Oh, that was weird, and that was so fast. That was like a Zoom glitch, I guess. Okay, so did you say something?
Yeah, I was wondering if we can talk later from for the class when the class ends. I
Sure.
don't know if that can be a possibility.
Yeah, that's fine.
Um,
That's fine.
okay, thank you.
Okay, so what do you do? What is probability A or B if A and B are not disjoint? So in other words, they're overlapping. You guys gonna put it in the chat? Very good, Nacha. So it's going to be that longer formula, A, probability, B, and subtracting the overlapping piece. Let me do it like that. Right. So what if A and B are not independent? What is the answer? How do I solve that? Oh, let me go back one bit. Let me go back one bit. So to finally answer A or B, if they are overlapping, not disjoint, I have to know A's probability, I have to know B's probability, and I need to know their intersection because they're overlapping. And okay, so what if we want A and B, but A and B are not independent. They don't have a special relationship so that both of them happening at the same time is just the multiplication. In other words, if A happens, it doesn't affect the probability that B happens. The probability of B happens doesn't change just because A happened. That was the whole thing. So what is the probability of A and B if they're not independent? It's right on that page there. In general, you have to know the probability of A and the probability of B given A. This means given. So it means if A happens, this is not a bracket. Let me clear that. It means I need to know, so I want to know the probability of A and B. And so I can calculate that as knowing A's probability, and then given that A happens, what's the chance of B? That's also the same as this. Knowing the probability of B, and then if B happen, what's the probability of A? That's the way you calculate it. Okay, and this is called a conditional probability. You don't just multiply A and B, you need to know specifically if B happens, what's the chance of A? Because it might be different. So I use the example of going to a salon just because I used to teach this class for nursing students, and like 99% of nursing students were women. I also taught social work students, and like 99% of the students were women. So I have this example that I think is useful for everybody. Guys, have patience. But so if I'm watching someone at the salon, the chance that they have their hair done and the chance that they have a manicure might change if they had one of the others first. Because why? Because they spent money on their hair. Maybe they don't want to spend more money on the manicure. Okay, so the probabilities change. That's what this is capturing, that it might not just be, it might not be just A. A might have changed because they did B. Okay. All right. All right. So I think I spent some time explaining the answer to that. Is that a good answer? So no, this rule is only for these cases. If not, you have to know some extra stuff, basically. You have to know this if it's or and subtract it. And here you have to know the conditional probability. You can't just multiply. What happens if they are independent? What does this become if they are independent? If A and B are independent, what happens to this? So if I go to the salon and someone tells me, everyone here has so much money, doesn't matter. Then if it doesn't matter, that means that if they had one of the services, their probability of having the other service doesn't change. It doesn't care. They have a lot of money. They don't care. They haven't, maybe time might affect things. They don't want to spend so much time, but sometimes they can do your hair, your nails at the same time. So, the probability doesn't change. You guys are giving me the wrong answers, but I think you're headed in the right direction. You're headed in the right direction. Something disappears. All right, so when A and B are independent, probability B given A is just probability of B. It doesn't matter that A happened. It doesn't change. And Nicole's right. That's right. Right. And Claudia's right. You just multiply. Right. Good. I don't think I spent enough time making this point, so I appreciate the question and I'm taking my time right now on this. Oh, sorry. Okay, so if they are independent, then the conditional probability just collapses and becomes itself. It doesn't matter that A happened. Think about the examples more than the letters. Okay, some of you are very strong in mathematics and you will lean to the symbols and you might forget about the interpretation. So don't forget the interpretation. For people who are not good at math, lean on your ability to understand the verbal, the problem in words, right? And then all the formulas fall into place, I hope. All right. So great. So do you want to, so I was going to give you some problems to try, right? Let's try a couple of problems until like, well, we'll just try a few problems. I will give you something here. Let me see. Something different, right? Because those were pretty basic, I think. A couple may have been challenging, but they're pretty basic. Hmm. So for anybody who came late, we're going to be discussing the review of all the tests. We're gonna go through the tests because you have next week to complete this set of notes because module 7 uses the same material as module 6. Well, the same lecture notes, but everything after remind me, what page did I say? Page 15 and forward, right?
Professor, you're muted.
I know, I muted myself.
Oh,
Okay,
I'm sorry.
I was doing something. Thank you. Okay, just finding problems here.
Could we try a problem like the quiz ones that require like more thinking, I guess?
Yeah, yeah. Yeah, I'm gonna give you something. Yeah. Mm. All right. So I'm gonna give you like, so we can do this 10 minutes. I'll give you 10 minutes so you can get a drink or a snack or whatever. And we'll meet back here at like a couple minutes to 10. Okay. All right. Try that problem. And there's a bunch of exercises. This is just the first one here, but see if you can do the first one. It's going to involve you. I don't know if you want to draw it or make equations or what you want to do, but I would recommend making a drawing and then you can answer the series of questions. Let's see if I can, let's see the questions. If I can copy these over, I think that's what I'll do. So you can see them all. Oh, it's not going to work. Let's see. Put this up. Yeah, it's not going to be possible to put them both together, but okay, so there's a bunch of other questions. Maybe I'll just put this. Maybe I'll just put 8 after at the top. Sorry. Okay, so get that one, 7 and 8. So try those, and we'll be back at 10. I'm going to pause the video. Back. I'm back. How'd it go? How are your drawings? I should ask you to show me your drawings. I would like to see those. Was the drawing difficult? How did you anchor your drawing? What did you look for? Oh, you want to show me? It might not be visible. Maybe you guys can, if you want me to see it, you can send me a photo, text it to me. That would be the best way if you want me to see it. So you need to know if they overlap and how they're going to overlap. To use the overlapping approach, you look for the word and. Okay, so these ones overlap because there's a result here, 22%. Let me use my iPad. So these ones overlap, wine and beer, and these ones overlap, wine and vodka, and also beer and vodka. So they all overlap with each other and they all overlap completely together. So that tells you that you can draw it 3 circles that connect with a center. The size of your event doesn't necessarily have to be to scale of the numbers because it's kind of hard to do when you're missing information. So don't feel bad if it's totally off. But you'll get an idea once you draw it and see if it makes sense. But these are just sketches, right? They're just like a model to work with. Are you guys sending me your pictures? I mean, your drawings? Let me see if you texted them. I can see any here. Just because it'll help me. No one sent one. Okay, you guys are shy. All right, so let me draw it. So I'm giving information on wine first. So let me take this aside. Let's draw it somewhere else and then I'll come back. Okay. So that's going to be my wine. Let me move this over a little bit more. So this is wine and this is 55%. And then I know wine and beer cross, so I'll cross them here. Beer is a little bit smaller. Maybe I'll make it a little bit smaller just so it doesn't get out of control. So beer, and this one is going to be wine and beer. So beer is 40% and wine and beer is 22. Do you guys like this question? Is this the kind of question it's different? It's a little challenging. Yeah. Okay. And then what else? Okay, so we've done these three. 6% by wine and vodka. Okay, now I'm going to bring the vodka. Now the question is, do I just do it here, the circle, or all through? Well, this one tells me all of them. So I can do all of them. If I make a circle for wine, vodka, I'm not going to make it that big because I've used quite a bit. This 22 could be bigger. Okay, I don't have to, it doesn't have to be perfect, like I said, but I could make it a little bit bigger because 22 is definitely more than what I've drawn here. Let me go back a bit. I'm going to go back to B and make B a little more covering like that. Okay, so this is 40% and 22 is in here. And then I know this is beer. And then I know wine crosses over vodka for 2%. It's very small. So I'm going to do vodka like it's kind of a blob. Make up. Okay, so then this is 2% in here. And what am I missing? So then they also tell you about wine and vodka. Wine and vodka is 6, so that's 6. And then they also tell you, they give you a lot here, beer and vodka. So this is not as hard as, they could be more challenging, but this is getting you to draw. I'm going to make this a little bit bigger too. So what did I say? Beer and vodka is 50. No, that's or, sorry. Beer and vodka is 5. Okay, so this is 5. This is 5%. Okay. Everybody got? Oh, good. Dorimar sent it. Okay. Okay, so yes, an I in the center is 2, right? Okay, so you guys, now that I've given you the drawing, so that's everything. Fix your drawings if you didn't get this. Okay, and then we're going to work on this one. This is the one that remains. We drew all the other ones. This one is going to give us the information we're missing. 55, 40, 22, 6, 5. Okay, so the question is, what is this? Vodka. That's the first question, right? So we want to know vodka. So we know these pieces, but we don't know this one. I don't know if we have to get it by sorting it out. Let me be clear about something, okay? This W is the whole circle. Wine is the whole circle. 22 is just this part. So what do we call this over here? Remembering all of these fall into a sample space. That makes 100%. Somebody can go in the store and buy something else, right? Something else is out here. Anything else? Okay, so the question was, what do we call this? What would this be? This is wine alone. They just went and bought wine. They didn't buy also beer. They didn't buy vodka, just wine. Okay, so that's different. So this space here is not 55. The whole circle is 55. The same with beer. The whole thing is 40, but just beer without wine or vodka, you'd have to subtract these off to know what's just here in this space, okay? But we don't need to answer that right now. Let's did this one. And I suspect that this bit of information will give us the answer. Let's check. Because I mean, I've done these problems before, but I don't remember. I just have a gut feeling. So let's write this out. So buy beer or vodka. So the probability of buying beer or vodka, definitely they are not disjoint, right? So what do we know? They're not disjoint. They actually cross, they overlap. So it's going to be B plus V minus B and V. What do you get? B we know. V we don't know. And B and V we know. Note also this 22 is the whole thing. So just this would be 20 because we know this is 2. All right. So be careful when how you draw it. I mean, that's how I've drawn it. If you drew it in a different way where all the pieces are separate, that's okay too. Just be consistent. All right. B and V is down. B and V we are told is this one, 5%. So this 5% is the whole thing, not just this piece. Just be clear. So maybe I can do that. Maybe I can do that better with drawings and colors, but okay, for now, BMV, I'm told, is BMV is 5%. And all of this is supposed to be 50. So what is the probability of vodka? I'm going to redraw it. I'm going to draw it in the way that I'm saying. I'll draw it again just to be clear, but let's answer this question first. So these have to add up to 50. So we have 40 and we have 5. No, we don't. We have, what do we have? Yeah, we have 35 to make 50. So what would it be? Dorimar 15, Mariangeli 15. Good. You guys can do the algebra or you can see it. So I would have to do 0.50 minus 0.40. I'm putting the zeros on just because, you know, they're 50 and 40 to distinguish them from this 5 over here. Okay. So it's going to be 15%. Good. So a few of you got it. I'm going to redraw it with colors. So wine is 55, beer is 40, 22, wine and beer. So what I'm going to do is use a color. Uh-huh.
Couldn't we have just gotten that number since wine is 55, beer is 40? Couldn't we just have gotten that number by subtracting the wine and beer and getting the yeah, exactly, and getting the vodka? Because it's also 15.
It might be a coincidence because you have the outside part too, but anyway, I just hold on, let me draw this. So this is beer or vodka. No, this is wine and beer, wine and beer. Wait, let me draw it here. So that's going to be 22. And then the 5% was bothering beer and vodka. So I would draw Oh, I covered it. Oh no. Okay. The point is that that 5% is not just this piece, it's the whole thing. Okay. And then this 6%, what's this? Wine and vodka, the same sort of thing here. So the only one you know is the middle of 2%. Okay, so your question was, can I do it? How did you say?
So because, oh wait, sorry, like um, because the wine is 55 and it's the whole, and then the beer is 40 and it's also the whole, we would have to get the whole vodka to be able to get, I guess, that 100%.
No, the
And
100% is everything, not just these, because we have outside. People can go to the mall, to the liquor mart and buy other stuff.
oh, okay,
We
so
don't
we
even,
can't do that because
exactly,
anything else. Okay.
right? So you can't use 100. It's a coincidence that it added up, but it's not necessarily. Okay, so this should be the drawing. It's not hard, just keep in mind like how you're going to draw it so you're not confused. But there's 2% in the middle here. That's terrible. I'll erase that. Okay, 2% in the middle, you have to remember. Okay, so ready for the next question? Now we have the drawing. We have V of 15. So notice the drawing, like this whole thing is 15. The whole thing. So I'm gonna do it like the others. This is 15, I know now. I know 15 and I know all the parts. I can find all the parts because I know anyway. So I've got a good set of information. So let's go to the next, let me grab the next question. Okay, the next question is, which of the followings is true? W and B are independent. Okay, so how do I know if W and B are independent? It means that this should be equal to this red should be how much? And so you check if this is true. What's W and B? Do we have that? We have W and B. Wine and beer. Wine and beer is 22%. And what's W? W is 55. And beer is 40. If 22 is the result of multiplying these two, then we would say they are independent. Is it true? What is 55 times 40? 22. Okay, so the rule is it goes both ways. If they're independent, you know this is true. And if this is true, you know they're independent. It goes both ways. So what does it mean in words? It means that if somebody, it means that, okay, 55% of the people, or the chance, let's say it like that. So so I explained that probabilities are long run relative frequency. What it means is that we have observed over a long period of time, and it turns out that on average, out of the people that go into the liquor mart, 55% buy wine. That's what it means. So if 100,000 people go in, 55% of them buy wine. So it has to be a large sample because you can't just say like two people go in and one of them buys wine. And no, they observe over a long period of time to see patterns. Beer. 40% of the people are expected to buy beer. If somebody buys wine, what's the chance that they also bought beer? That's the question we're answering. Does this change? If they're independent, it doesn't change. It's still 40%. When will it change? It'll change when people maybe they feel cash constrained, or there's inflation, and then they just decide if they buy wine, the chance of buying beer goes down. It'll change that. But as is, if they're independent, it means that the probability doesn't change. So the answer is A, but let's check the other ones. You should always check the other ones. Any questions about what I just said? Okay, so it's both ways. If you know two events are independent, you can multiply them to find the probability of them happening together. If the math works out that this equation is satisfied, then they are independent. It goes both ways. Ready for the next one? Are W and B mutually exclusive? In other words, are they disjoint? This is false because they overlap. How do you say overlap in Spanish? That's the one word. That's right, it's false. Convergen. Okay. I was trying to use a translator yesterday to translate something to Italian, just so simple, like how's it going? And I couldn't find, because I know Italian, but I was just thinking, how do I actually say this? Say, and it was giving me such weird translations, like people don't even talk like that. So anyway, that's why I'm asking you. Solapar. Okay, convergen. All this AI is going to change the way we speak. That concerns me. I don't want to have a computer tell me how to speak. But anyway, that's an aside. All right, so what about the next one? W and V are independent. Okay, so you guys check that without me. Try that one. Are W and V independent? Yes, yeah, all the dialects. Italian has lots of dialects. I don't know how many, but I know of every region has its own. I don't know, did you guys hear that noise? I just moved my microphone. Hope that didn't make too much of a noise. You're checking C. Sorry. So we're going to do the same thing. If W and V are independent, then probability of W and V is equal to the probability of W times the probability of V. So let's check. W and V is information given to me here. Wine and vodka is 6%, but wine alone is 55, and vodka alone, we figured it out. You wouldn't be able to do this problem without figuring it out. So 0.55 times 0.15 is 8%. So it's false. Good. So it means when you buy, if somebody buys wine, their probability of buying vodka goes down or goes up or changes. Okay. And the other way around too. If somebody buys vodka, their chance of buying wine changes. It's not going to be 55. It could go up, it could go down. Okay, so this is false as well. And WV mutually exclusive? No, because they actually overlap. And B and V are independent. B and V, so you can check B and V as well. I'll leave that for you guys. So that's not. Okay, it's not because we have the answer. But we should check them actually. B and V. So if I multiply 40 and 15, do I get the blue? Do I get 5%? So 40 times 15. I get 6, not 5. Okay, so it's false as well. Good. Okay, you guys feel smarter? The one I just did, I did 0.4 times 0.15 and 6%. Maybe Marangeli did it too there. Mariangeli. Mariangeli. Okay, I'm getting it right. All right. Okay. Shall we do something else here, or should we go to the tests and review the tests? Oh, you're going to tell me if you want the test today. So let's have a vote. Yes or no in the chat. Do you want another test today, a probability test today? Just on the pages up to page 14. Just continue review? Okay, just continue review. Like I said, we had time. Okay. Someone's going to be scared to to say yes. It's a mob. Okay, you guys, let's continue review. So should we do another probability? Okay, let's do another probability. Are you guys good with this? Do you want to take a screenshot or let me make it big? I mean, you could do it in the video later too, but just you never know what happens. I could lose the video. You want a screenshot because you understood this. So this is a little expansive beyond what you've been studying, right? But the same rules apply. The 6 rules, no, it's 5 rules are, is it 6 rules? Oh my goodness, can't believe that I'm asking you guys. Is it 6 rules or 5 rules? All right. 5 rules, 6 rules. Yes. Okay. 6 rules is the last one. Sorry about that. So the 6 rules will get you pretty far. Let's look at, I'll get you another problem. Oh, there's more problems with this one, but yeah, let's do the other ones too. Okay, so I'm gonna grab that drawing. I'm gonna grab the drawing and let's see some more. At least one more, and then we'll go. So we invested a lot in this problem. Oh, I can't do the rest because you need the rest of the unit. You need the rest of the module, so I can't do the rest. We'll come back to this next week then, and I'll do the other problems when you guys finish the module. Okay, so I'll look for a different probability problem. So this is not a substitute for you guys getting through the notes, right? And the videos. Make sure you get through the notes and do all the problems. All right. I'll give you a few minutes. A recently married couple plans to have 2 children. The outcome of interest is the gender of each of the 2 children. Consider the event that exactly one of the couple's children will be a boy. Which of the following is the complement of this event? Okay, I'll give you a couple minutes for that. Okay, so what we're talking about, just to recap, is the outcome of interest is the gender of each of the 2 children. So the sample space is made up of 4 possible outcomes because the first one can be a boy or a girl. That's 2 options or alternatives or possibilities. And the second is 2. So that's 4 possible outcomes. Now, we define an event from that sample space. It seems like it's supposed to be simple, but do it step by step, right? Like the way I outlined before. So consider the event that exactly one. Oh, before I continue, what are the probabilities of each of these? There's 4 possible outcomes. The probability of being a boy is 50%. Either way. So each of these outcomes is equally likely. So each one has 0.5 times 0.5 or 0.25. In other words, a quarter, right? They're all equally likely. They're all 1/4. 1/4, because they're all the same, and the sum of their probabilities equals 1 or 100%. So it's 1/4 each chance. All right, so now the question, which of the following is the, oh no, sorry. So the probability, consider the event that exactly one of the couple's children will be a boy. So the event of one is a boy includes which of the items in the sample space? So let's make that event. So probability of the event, I'll call it event X. X is exactly one boy. So which one of these is exactly one boy? Those two. Regina, all the probabilities for a sample space must be one, just like the drawing here. Oh, I don't know if I'm going to find it. Let's see. Wait. The drawing we did together. Remember I told you all of the things in here have to make one. It's the same thing. 100% fill the space. It's important. I'm glad I said it to remind you. Sorry, I have a lot of stuff here. Okay, so it's these two. Okay, so I'm showing you English problems because these extra problems are not translated, but like usual, the quiz and the test, the final will be translated. But these are very specific terms, right? At least one or exactly one. I hope that translates well. So how would you say that in Spanish, exactly one? Precisamente una? How do you say exactly one?
Yes, you said it right, Professor.
Okay. Probably couldn't spell it, but is it right? So exactly one boy is this one. So this is going to be, I don't think it's asking for a probability, it's asking for the event. So I can erase this, but we can call it X anyway. So what's left over? If it's exactly one boy and that's those two in the red, what is the complement of that? It's the other ones. 2 boys or 2 girls. Got it? So I would write the complementary event is the same gender. Which of the following is the complement of this event? 2 boys, 2 girls, at least 1 girl, 0 or 2 girls. Okay, so that makes the most sense. Same gender. the same gender. It's a little bit head spinning here. Okay, so it's those two. Now, how are you going to say that? So I guess the vocabulary, the language isn't really important here. So how would you say this? Boy and boy and girl and girl. Two boys, no. Two girls, no. One girl, no. Because if this is part of the answer and this is part of the answer, but I need both of those to be the complement. At least one girl, no. Zero or two girls. So that's the way of saying it. So it would be E. So it's just like if you guys did this on a test and you wrote the same gender and you didn't know which one to pick, I'd give you the points, because it's not so clear.
So the answer was not in the question?
No, the answer is E. It's just the way they said it. They didn't say same gender
Okay, okay.
or two girls. It's just said in a different way than I would say it, right?
Okay, but the answer is E.
It's E, yeah.
Okay.
Okay, who chose E? Let's see, give you guys some praise here. Okay, Kim got it. Kimberly, good job. Okay, Nicole. There's some confusion about what I'm doing here. Exactly, maybe this would lie. Okay, and Dorimar. Okay, good. So that was another challenging one for you. Um, yeah, you develop your confidence as you go. Try and do as many problems as you can. These ones are not, these are extra problems that I have. These are old exam problems. You guys have a lot of problems. I don't want to give you too many problems, but I mean, you guys can, take screenshots of these and add them to your materials. Yes, Ernick. One has to be a boy, and that leaves the other two. Yeah, my suggestion is when you have multiple choice, don't look at the options until you've thought through the problem because it might guide you on the wrong direction. If you're really stuck, you can look at the options, but try and illustrate your problem before you look at the options. Because the options may trick you and bring you down the wrong path. Okay, Ernick, why if the exactly one will be a boy, this phrase is like forcing that one in the future is a boy. Yeah. It's just to test you. Sorry, hiccups. Nicole, are you okay? You wrote me a note. I didn't see it till now. Right.
Oh, yeah, it was just the picture. I sent it to you.
Yeah. Let me see. Okay. All right. Ready to do the test reviews, or would you prefer if I did the test reviews in a separate video and we continue reviewing together? Do you want just to continue reviewing together probability and other things, or do you want me to do the test reviews? I have like an hour left. Test reviews. Okay, so test reviews means I'm going to go over the answers for the test that you guys did. Yeah, put it in the chat. Okay, we'll take a vote. Okay. Well, you guys were tied on this one. Okay, why don't I'll review last week's and then you guys tell me if we want to do more of the test review. Because I did a review with a couple of students. Okay, one more probability and then we'll do the test review from last week. How about that? Okay. Okay. All right, so let's see. Let me find some more. Let's take a 5-minute break, you guys. Let's take another break. Refresh. Get up, walk around. I'll pause. All right, here are two problems. Try these two, and then we'll look at the test from last week. I didn't do an overview of them, the rules, but you guys should have those somewhere, right? The 6 rules written somewhere for you. It should be on a outline or study sheet. I didn't have my microphone on this whole time. I hope you guys could hear me fine. This will be way better. What happened there? Let's see. How did I miss that? If you had trouble hearing me, this is probably why. Oh, okay, it's not plugged in. Oh, what the heck? And now better. That's why you guys didn't hear me when I grabbed the microphone and made a lot of noise. All right. I guess I should pause the video while you're working on it. Okay, I'll pause the video again. So just to recap, if any of you are interested to learn about the Bloomberg terminals and you're on the island, I'll be available from 1 to 5 in the Osuna Library, second floor of Osuna, in the finance faculty. In the business faculty. If you want any details, just text me and I can give it to you. And I'll be there Saturday, 1 to 5, the next few Saturdays. Okay, should I do these? You ready?
Professor, just letting you know that in the Spanish version of the tarea, we don't have the multiple choice options.
The answers or the...
The options.
Oh, they got cut off? Okay, but you can go to the English one and see it?
Uh,
I can fix it, but I'm just saying, can you see
I
it?
mean,
Is it in the English one?
I'm not sure because I always download the Spanish one.
Okay, so in the Spanish, in the notes or the homework? Oh, you said the tarea. Okay, let me see that tarea. Tarea de práctica.
Mm-hmm.
Which problem?
Number 4.
I think you just have to give the answer. No hay
Yeah, okay.
opciones. Yeah.
Okay.
Yeah, sometimes it's options, sometimes it's questions. Yeah, so it's just open like that. Good, thank you. All right. Ready? This one could be, the first one could be a bit confusing because I'm asking you to do something we haven't done. So you're going to list the outcomes of interest. You can call them gold, silver, and copper. And then just list all the possible outcomes of the three, right? So there's three. Is it three or is it two? Okay, so this is, I'm going to use the same placement idea. There's three you're going to choose, but it says without replacement. So this is different than the gender of the kids, right? Here, whichever one you choose here, you can't choose it next time. So in the first choice, you have three options. It could be gold, silver, or copper. How many possible outcomes on the second? So the first one I pick, it can be three options. And the second one, how many can it be? Only two because I picked one already. And in the third, there's only one left. So this is a way to figure out how many there are. So there's going to be 6 possibilities if that's how I choose. So I'm going to list all the possibilities, but then I'm going to answer the question. So it could be gold, silver, and copper. I'm going to keep the first one in place, or gold, copper, and silver. If I pick silver first, it can be silver, gold, and copper, or silver, copper, and gold. How many of you guys are on the right track or understanding it properly? Copper could be copper and gold and silver, and copper and silver and gold. Those are the 6. That's what without replacement means. You don't put it back, which is realistic, right? You pick it. So, and this is how you figure it out. This is called a factorial. This is also written as 3 factorial. I'm sure it's the same in Spanish. And you may have may not have seen that in mathematics or MECU or whatever math class you took in your bachelor or even in high school. But you don't need to know what factorial is. It's just logical. You pick one, then you have 2 left, and then 1. So 6 possibilities, and here they are. Now, let's identify the ones that correspond to the statement here. The outcome of interest is the sequence of colors that are selected during this process. What process? You pick until you get a gold coin. So which ones would it be? You pick until you get a gold coin. Either in these two, it would just be G, because you stop picking. In this one, it would be SG and SCG, because gold is at the end. And this one would be CG and CSG. Like, doesn't have to be so confusing, but apparently it is. So we have to modify, because this is how we would do it without this provision, until the gold coin is selected, and then you stop. I promise you, if you do enough problems, they won't seem different. Like the problems I've given you are pretty straightforward. This is a little bit different. But now we did it. So how many do you count? Okay, good. Nacha, good. You guys understood. Yes, Dorimar, exactly. Okay, you guys understood. Fantastic. Okay, good. That was just like a word problem. You just you have to begin by looking at them all and then translating them into the stopping statement. Do you need more time for number 5? Okay, let's give another 5 minutes. Okay, so 5 more minutes. I'm going to pause the video. So 11:15. Put it back. Okay, let me just show what we did for the last problem because it didn't end up on the recording. Okay, let's put it. Okay, so this is what we solved after the break. So we went through here and we had two pieces of information that we had to combine. So this is the result of them being independent. Since they're independent, we know A times B is the same as A and B. And we don't have otherwise any other information about whether A and B are disjoint. So we need to use Rule 6 for A and B are disjoint, not necessarily disjoint, and then plugging everything in. The main thing was we substitute this result about independence into here. And then we see that we only have one variable unknown, and that's the one we want. Okay, so then we do just some algebra, or I suggested all you have to do is try each value in the formula to see if you get this result, 0.735, and you would have had your answer. But I did do the algebra, and I showed how you could solve it. So that's for people who are not in class. I think most of you guys are here, though, how I got the answer. And I asked everybody if they want to do the review now, so we're doing the review now. I also, review of the tests. I also suggested that I am not going to be giving class on October 25th. So maybe on the 24th we can have a review class or something. I just can't meet on the 25th, but it will be like a, unofficial class because it is on off time, but I will record it and then share it. So that will just be to review, like today, like we're reviewing tests and things. So remind me if I happen to forget, but we can do on the 24th. We'll have to figure out a time, probably the evening. So that would be a Friday evening. Let's make it like 2 hours. So, it doesn't eat up your evening. We can do like 6 till 8 or something. Okay. So let me write that down because I don't like people like the routine, and I also like the routine of getting together. So that would just be a review. There's no tests or anything, but that would be like today, just kind of reviewing the old tests and things like that. In the morning, I can't. Yeah, it would be at night. It would be like a 6 to 8, something like that. And then I'll record it and post it. That's the best I can do. I'm traveling the next day. If all goes as planned. Okay. All right, so I'm going to share. Sorry, I was sharing the platform. Oh, and I have to post Connect. What I'm going to do for Connect is post 2 assignments in Connect. And they're mainly for you guys to practice, but also because you're going through them, you're going to get like 10% of your grade. So it's an easy 10% if you do it. If you do it properly, even better. No cheating. Okay, so that's the class. This is the test. Oops, I missed it. This here. So you're seeing my view. Oh, is it closed? I have to open it. Hold on. Oh, because I'm on your student mode. In my mode, I see everything. Okay, here you are. Okay, so it comes up with this one first. Let's try the other one first. Well, which one do you want? Do you want this one, Green Harvest, or the other one? They're both about sales and marketing budgets. Couldn't escape it. So who wants the Green Harvest? We'll just have time for one. Okay, both if possible. Oh, Maidangeli, so did you get the textbook? Connect textbook? I guess Green Harvest is longer because you have to actually make the calculation. In the other one, I just made you interpret. What was I answering? Oh, Connect. Okay, so for Connect, let me go back. If I can go back. So here I have information on how to get Connect. And here. Was it blocked? Oh my goodness. Well, thank you for the question. It shouldn't be blocked. It's available. Okay, well, I'll verify that. Let me see. I have to unblock it. Let me make sure it's the right one. These are all the things I have and hidden from you. Here, this is the Connect information. Okay, so maybe I didn't update it. That's why. Okay, so I need to update it, but you'll find it here right before, like at the bottom of the intro material. Connect registration details for the Bowman textbook, okay? And let me go back to the quiz. Close your eyes, close your eyes. Okay. So let's see. Green Harvest, second one. Green Harvest. Okay, so it's kind of, everybody wants both. Let's do Green Harvest first. All right. So, sorry, I have to read the English one because I'm not so great in Spanish speaking. Okay, you're a business analyst for Green Harvest, an organic food retailer planning to optimize its marketing budget. The company has collected data over the past 8 quarters on quarterly marketing spending. Oh, I guess, sorry about that. And corresponding quarterly sales revenues. The data set is as follows. Green Harvest is considering increasing its quarterly marketing budget to $10,000 to boost sales. However, the marketing director is concerned that seasonal demand fluctuations and a recent competitor entry might affect the reliability of a simple linear regression model based on this data. Calculate the slope and intercept of the simple linear regression equation. Okay, let's see what's going on. So we can take this to Excel, right? We can draw a scatter and do the analysis. So let's do that. I don't know why it says spending. So marketing, I'm just going to call it marketing. Sales. And then 50. I need my, let me move this. It's getting really dark in here. I have to turn lights on. You guys can't see it. It looks good on your end. $60, 45. You guys can do it too. 70, 55, 65, 40. I'll show you once I'm done. Oh, I guess you want to watch me doing it, so okay. No. Right now, can you open the test or you can't open it? Can you see the questions? Did you want to take a picture of the question? I asked you a bunch of questions at once. Oh, you can see it? Okay, good. I mean, on your end, on your computer, you can see it. Okay. I always have to make things pretty. Okay, 50, 60, 45, 70, 55, 65, 40, 75. And these are quarters 1, 3, 4, 5, 6, 7, 8. 2 years. And sales 120, 140, 110, 160, 130, 150, 100, 170. Okay, so we're going to highlight and then insert chart. I'm going to make the scatter plot. Well, I don't see any fluctuations. Do you guys see fluctuations? Looks like a straight line to me. Fluctuations would mean it was like higher in some, like every second quarter would be the same in somewhere else, and every third quarter would be the same in somewhere else. So there's actually no fluctuations. Let me make sure. 120, 110, 150, 110, 170. So, oh, I see what they mean. I see what they mean. It does fall on a pattern, but you will see that it's done because it's done in numerical order, right? It's done in numerical order and it doesn't go up steadily. It's like, let's highlight this one is the first quarter, and this is also the first quarter of the second year. So let's put together the ones that are the same. Let's see. So you don't see the fluctuations there because they put them all in order. But probably these two are from the same quarter, and these two are from the same quarter of the year. So let me call this, I'm going to call this year 1, quarter 1. And this one is year 1, quarter 2. So you guys get the idea. And this is year 1, quarter 3. And this is year 1, quarter 4. And then this is year 2, quarter, so it's 5, but it's really quarter 1. And then this is year 2, quarter 2, and year 2, quarter 3, and year 2, quarter 4. Okay, so you're not going to see it in the overall scatter, but you will see if I color these. So the second quarter, 150, 140. Okay, which one is 75? Okay, that's the highest. So I'll do this one in blue. Okay, so in the fourth quarter, of each year, it's the highest. In the first quarter of each year, it's the lowest. Okay, so these are grouping together in a way that it all falls on a line. You don't see the fluctuations this way. You see it when you group by quarter. Do you understand? So maybe I'll make a note. First quarter, always lowest, not always, but now it's raining. No, somebody's not here. Someone. So last quarter, highest, and I mean the highest of all, right? In year 1 and 2. Preguntas. You guys following? So that's what they're talking about, the fluctuations. But the pattern is there. If they spend more, they get more sales. Punto. All right, so now let's get the information. So how do we do that again? Do you guys remember? Okay, my titles aren't very good on this, so let's write it. How would I write the title? Which one is Y? Sales, right? So sales versus marketing. And you have to write it like that. Sales versus marketing. Sales is the Y, marketing is the X. So how much they spend results in more sales. So let's do, how do you guys remember how to do this? So we highlight the chart and double click it. And then we see here, we can add the trend line here and then ask for, oops, what happened? Trend line and then more trend options. That's what we want. More trend options. You have to click on the histogram looking thing over here and highlight display equation and R square and move it over. So this is a perfect, it's perfectly fit on the line. I want to make this bigger. How am I going to do it? No, I'm going to change the font. If you guys can't see clearly, let me know. There. So there's the equation. It's a perfect line. So R square will be 1 because R is 1 and then R square is 1 square. So it's 1. It means 100% of the variation in sales is explained by marketing. That's how you interpret that. And now let's do the slope and the y-intercept. So let's write it down. The slope equals to, what does it mean? So we look at it as 2 divided by 1, which is also the change in sales divided by change in marketing. All right, so that's what we're going to use. So we start from the bottom. For every additional dollar spent in marketing, how do you finish the sentence? Not say it better. Say it in a better way. You can say it in Spanish or English. How do I? And for each additional dollar spent in marketing, How many dollars will we have in sale? Okay, Dorimar's making it more practical. We'll start with the simple. So for each additional dollar spent in marketing, the firm makes 2 additional dollars, right? And so for each additional dollar spent in marketing, the firm makes $2 more. So like Dorimar says, we can say it for thousands. So if we spend $1,000 in marketing, how much or more are we going to make? 2,000. Okay. You got to say it clearly, guys. All right. So that's that. Now, what about the intercept? How do we write that? Intercept. What is the intercept? If you haven't done it, make sure you do the homework from module 5. I think it's very good. And any questions, you let me know. Do everything I give you, but I'm just saying if you missed something, I'm just highlighting some things you shouldn't miss. So y is 20. What does it mean? So it means on terms of the picture here, it's where this line hits where x is 0. So it's going to hit 20. So this is going to, if I extend this, why don't I extend it? Why don't I extend the line? Why do I just leave the line over here? How do you explain? Why don't we drop the line all the way over there? Right, Claudia. So we only use the data provided and the relationship only exists over here. Okay, the relationship between revenue and spending is over here, so we don't go too far outside. We can speculate that if we spend a little bit less, we would make less, and we spend a little bit more, we would make more. You can speculate, but going all the way over here is an extrapolation, and we avoid that. Yeah, we avoid extrapolating. But having said that, the equation to make that line over there, we still need to know how, where it is, like up or down, and that 20 guides us. So when the interpretation of y-intercept is when x equals 0, y equals 20. That's what that is. Okay, so that's literally what it is, but now let's explain it in the context of the problem. So how would you say that in words? So you guys wrote something. How would you say that in words related to the problem? And this is in thousands of dollars, right? So let's go back here because I'm kind of ignoring that. In thousands of dollars, right? X is in thousands. So let's interpret that in thousands. So exactly, Dorimar. So if we don't spend anything in marketing, we still make 20,000. Okay? Without spending anything on marketing, the firm earns $2,000 or 20,000 in sales. Okay, that's what it means in terms of the problem, because everything was in thousands of dollars. They just rounded it. Okay, so they could just by reputation, family and friends. They don't need marketing, just word of mouth. Maybe they have specific negotiated, just, they're distributing to certain buyers, so they don't need to do sales. I mean, marketing. Okay, so that's what it means. All right, let's make a prediction. So we did slope intercept. Oh, what is one potential limitation of the model given the seasonal fluctuations and competitor entry? Any comments about that? Let's read again what it said about competitor entry. Okay. So this data doesn't include the competitor, having a competitor. So yeah, we need to see that data. That would change things for sure. Lurking variable is usually used to explain, but that would be a whole different thing. It would change the relationships, right? If it could change the relationship, maybe we have to spend more. So this is all you have to say, something like maybe we have to spend more to get those sales. I don't know. So no, it's not exactly confound, because confounding has to do with, well, let me think. They would, I'm trying to think in the language, because they're not in this relationship right now that you're looking at. But if we had that information, the competitor didn't enter yet, we would have to include it. Otherwise, we don't have to include it. See, because confounding variables are for our explanations that we would have to account for. If we wanted to understand the impact of the competitor, we would have to record. I mean, it's just going to change things. It's not exact. See, we don't have to collect information on the competitor because we could use our model, but then we can have it like after the competitor enters and do the same model. So the main thing is that it'll change. We might have to spend more to get, so that's what is missing, right? We don't have the competitor information, but we anticipate that if the competitor comes around or enters the market, we probably have to spend more to get the sales we're getting. So it might shift, like this whole thing might shift up. It could change it could change or flatten our curve. I don't know. It could change the relationship. So basically we don't know because we don't have the data, but we suspect that it will change the relationship. And as far as the other thing, what was the other thing? Fluctuations. The fluctuations, it would be important to know, well, okay, clearly the more we spend, the more we make, right? The more we spend, the more we make, and it is captured in this relationship. So I think the regression captures the seasonal fluctuations in this case because it all falls in a line. If you are in a different period of time, so let's say these are in the first, right? This is in the first quarter, and over here is in the fourth quarter. The equation still captures it. So the equation, it fits. So it's not, it's captured in the line. All right, so let's make a prediction. Use a regression equation to predict the sales revenue if the marketing budget increased by 10,000 from the current average spending of 58,750. All right, so let's see if you guys can do this. Okay, it's already 12. It's already 12. I'll finish this and then we'll go. So how will we do this? So the prediction, you're going to use the equation now. Okay, let's answer the second part of this. Assess the reliability. How reliable is this prediction? How would you answer that? How do I assess reliability? Does anybody know? So how do I assess what thing on this here assesses of reliability? What do we look at? Tell me in there. Nicole, 100% of the variation in sales revenue is explained by marketing budget. That's the director can trust the reliability. Excellent, Nicole. 100%. So it's the R square. It's reliable because it's perfect relationship for the prediction. Now there might be other factors that are being captured here, but whatever it is, it's captured, right? Like we're actually capturing with that marketing measure. It's a proxy for anything else. It's marketing is driving sales. Marketing could include other things that are also predictors, but whatever, marketing is a proxy driver for sales. It's the only thing we seem to need. Okay, and R squared tells us the relationship is reliable. All right. And so now let's do the estimation. So if the marketing budgets increase 10,000 from the current, what is the predicted sales? So 10,000 from the current, 58,750. I mean, I think you can just predict what it is. You want to predict the increase from 58,750 to 68,750 in marketing. How does your sales change? If you just predict it at 68,750, what do you get? So you're gonna put the 68,750 in here in the equation. Oh, do we put 68,750 or do we put 68.75? And then we add 20. What do you get? Okay, so we're predicting at 68,750, but everything is in thousands. So we write 68.75. And you guys give me a number, 157.50. Now, what was it at 58,750? So we need to find that. So these numbers are not here, right? You have some numbers that help you draw the line, but so we have to calculate it for both. Oh, this is kind of tricky too, because you don't usually calculate for both. So 2 times 58.75 plus 20. What do you get for that one? And then the question is, how much more do you make? $137.50. So how much more do we make? $20,000 more. $20,000 more in sales. Okay, was that the question? Let's see. Okay, I don't have time for the next one. Let's see, questions. Okay, no problem, everybody. Okay, so is that okay? Is that better? Does that help? So I'm going to go through. The other one also was interesting. Maybe I can make a video of the answers for the test so that we don't take class time. But that's what I can do. Okay, so I'll answer the tests on a video and I'll post it. Okay, so have a good week. You're going to finish now probability, the whole thing. This weekend you're going to work to page 34, I think it was. And then during the week, you're going to finish all of it, right? To page 34 was just from the module 6 part. And then next week, we're going to finish probability together and have a test on probability. Probably one question from module 6 and one question from module 7. All right, so you have a little time with this break to work on both. And we'll see you guys next week. Like I said, I will be there in the lab today. If anybody's interested, I'll see you there. But text me if you're coming so I can look for you because the door will be closed. Thank you.